What you're about to see represents 6 months of toil, skin knuckles, exploding circuit boards, and most likely the loss of countless brain cells due to my unrestrained use of brake cleaner. Was it worth the few years that I probably shaved off my lifespan? I don't know. Maybe. My vehicle of choice for this installment of Conversions with Jeff, like I had a choice, is a 2-wheel drive red double cab Toyota Hilux from 1998. Same age as me, as a matter of fact. Make the point again.
The coolant looks especially green today.
So, engine's out. What next? Well, I decided the easiest thing to do would be to spec out the battery. I bought 31 Generation 1 Nissan Leaf modules. These modules were roughly at 70% of their original capacity. So all up it provides around 10 kilowatts of energy. Enough to keep the kettle going for 5 hours. Yeah. Keep the kettle going for 5 hours. Plenty enough for farm use. Well, it's raining now. Absolutely lovely. Next step in the parts acquisition process was finding a suitable electric motor. One of the most crucial elements to this whole conversion, one might say. The power of the original diesel engine was max 80 horsepower. So I wanted something that would output roughly the same peak power. Doing some research on the internet, I found that forklift engines were quite common in these sorts of conversions. Because like if you want one of those newfangled electric motors in the right power range, you're looking at 4 to 5 grand New Zealand. So if you can get a forklift motor secondhand for a few hundred, then there you go. So yeah, I just had to find a second-hand forklift motor. And after some calling rounds, I found a lovely old guy in Dunedin with a few forklift motors going spare. And a few days later, in 800 kilometers of driving, I had myself an ancient 100 kg series wound brushed DC forklift motor. God, they don't make them like they used to. Fuck, I nearly took my back out lifting that hunk of iron around. The nameplate on this motor gives a continuous rating of about, I don't know, what was it, 10 horsepower at 67 volts. I measured the winding resistance to be about 0.2 ohms, and I decided that given the number of Nissan Leaf modules I had, I reckoned a system voltage of 120 volts was about right. From this, I could calculate the worst case power consumption, which is what you get when the motor is completely stalled. I think, correct me if I'm wrong. And yeah, with those figures that I just gave, that came to about 96 horsepower, which is at 120 volts above and beyond the current draw of 2 Nissan Leaf modules in series. So one would hope I'm never actually stalling the motor. So where to put these Leaf modules? keep them nice and safe out of the weather. Well, I'm inherently lazy, so I went the easy route and just plonked them in an old aluminium toolbox. That bad boy that you can see somewhere in the video is supposed to be weatherproof. I won't go through the whole process of hooking the modules up, but it essentially involved a week of cutting, drilling and crimping, cutting and drilling all the copper bus bars, also cutting and drilling of all the structural aluminium components. Don't want those Nissan Leaf modules jostling around willy-nilly, do we? Where are we at now? Got to go over there somewhere. So, right. I have all the battery modules nicely organised in a big silver box. Now I need to sort out the battery charging modules and other nice things like motor controllers and DC-DC converters. And yeah, just a small note regarding the BMS. I did decide to not buy one and make my own one. Bit of a mistake. So the motor controller I bought is actually quite cool. It's a Kelly controller variant for all you motor controller connoisseurs out there. But it allows you to program in a range of different parameters. Like what? I don't know. Max torque, I don't know, voltage, cutoffs, all that sort of stuff. It even has an option for some regenerative braking. Quite nice. Where we at? I do actually have a script here, so I'm not just coming up with this nonsense off the top of my head. So yeah, while I was speccing out all the electrical components, I also started designing a motor mount in SolidWorks, the thing that's going to couple this forklift motor to the whole clutch housing thingy-mabob. There's a rainbow over there. I don't know if you can actually see it in the video, but let it be known that there is a colourful arc in the sky. So for the mount, I had two options. Either I could couple the motor directly to the transmission. This method is easier, but I no longer have the ability to do 6 skids by dropping the clutch. Everyone needs a clutch in their car. But yeah, I no longer have the clutch. Or I could keep the ability to drop the clutch and do 6 skids, but at the expense of greater complexity. Essentially, it provides a mechanical failsafe. So if your motor controller blows up and for some reason or another, your motor's going at full tilt and you have no control, all you need to do is press that old clutch pedal and you are no longer mechanically coupled, or your wheels rather are no longer mechanically coupled to the motor. Quite nifty, I do say. I set about recording measurements and re-recording measurements and re-recording measurements. Yeah, engineering work is expensive, so no reworking allowed. Now the hardest part was capturing the hole positions around the clutch housing and finding the central point in this weird shape that the clutch housing forms. Ooh, careful Jeff. Yeah, fortunately there was a metallic spacer between the engine and the clutch housing, and from that I could trace around it and then trace all the holes and even trace a nice circle in the middle. So I was able to scan that trace and chuck it in SolidWorks. Just a quick wee note, if you're trying to scan a drawing that you want to be dimensionally accurate, don't use a flatbed scanner. They mess it up. Yeah, they kind of squish out the paper and then all your dimensions go off in one dimension. So now, trace this scan drawing in SolidWorks with the old trusty spline tool. That gave me the main mounting point to the clutch housing, and then from there I designed a few bits and pieces that couple the shaft of the electric motor to the flywheel for the clutch. So I had some nice CAD drawings. The next step was finding a machine shop and turning those 3D models into glorious hunks of metal. And then while waiting for the parts to come back, this took 6 weeks mind you, I entertained myself with designing and building the battery management system. Yep. BMSs are cooked, and not only in the literal sense, I did manage to cook quite a few. So I found the schematic for a BMS on GitHub, and based my design roughly on this. If you're wondering, my BMS is based on the trusty ESP32. If there's any sign of divinity in this world, it's the ESP32. And then for the actual BMS chip itself, I chose, unfortunately, the Max 14921. Don't ever use the Max 14921, it sucks. I also potentially suck at PCB design. Like, I blew up 4 of these chips trying to get my PCB working. I guess that's mostly to be blamed on my bad soldering, but like, I also blame it on the poorly designed pinout of the chip. Who the heck puts a 60 volt input right next to the regulated 5 volt output? Like, these pins right next to each other. One accidental solder bridge and that chip is like gone, fried. $15 down the drain. So yeah, anyway, I got all the parts back from my motor mount, and that was a truly glorious day. A few beers later, and all the parts fit together beautifully. The motor and the clutch assembly were ready to be mounted to the clutch housing. So yeah, I flogged an engine hoist off a mate's mate and set about getting the forklift motor partially mounted. The front mount at this point was yet to be fabricated. That was a task for later, I had told myself at the time. But yeah, it all just fit. First time round. Who would have thought? Like, these are precise parts, like you have to get everything quite central. So now, the motor was attached to the transmission, and then I set about checking to see if a spinning motor equated to spinning wheels. So I hooked up the 12 volt car battery, and sure enough, the wheels spun. Clear indication that the transmission shaft was aligned with the clutch and seated properly with the pilot bearing and all that carry on. So here I was, thinking I'd done all the hard work. I mean, the wheels were spinning. That's like basically job done, isn't it, Jeff? Absolutely feckin' not. My BMS was still haunting me in the background, and more pressing, I needed to design and assemble the front motor mount. I had decided that I could fabricate this mount all by myself, just with a bit of sheet steel plate rather. All I'd need is a welder and an angle grinder. Easy peasy. Well, yeah, it was kind of straightforward. After a few days of turning steel plate into dust with the angle grinder, I had something that vaguely resembled a mount. God, you really can do anything with a welder and an angle grinder. So, I had the mount, but I needed to install all the other bits and pieces that are essential to the good operation of any automobile. Namely, that throttly bit, what do you call that? Variable resistor. You got a brake booster pump, speed controller, big heckin' main relay, DC-DC converter, relays, power steering pump and mount, cabin heating, and then the rest of the battery charging and control electronics. God damn, that was like many weeks of wiring, crimping, crawling under the ute. Yeah, I won't get into all the details. This video that I've made really doesn't do all that work justice, but let it be known, it was indeed weeks, if not months, of work. This is where we're heading, by the way. Camera turn around, we're going up there, and then we're going down there, and then way back out there. I'm just taking a wee break, going for a walk, and then I'll run down. Look at this quaint little wheat hut. Very nice. Unfortunately, there is no water. And, I'm out of water. Quite thirsty. So yeah, where was I at? Yeah, now we have the power steering unit mounted in the ute. We actually have power steering that works. And all that was left to do was actually take the ute for a test run. Out on the streets. All, you know, completely legal, yeah. It was well and truly tested. I won't go into the details. And then it was just a matter of packing her up and shipping her home. Yeah. So we shipped her off to the farm, and let me tell you, I can't really put words to it, but it was just amazing. All those months of work, and then you get to do some four-wheel driving at the end of it. Pretty steep.
The camera doesn't do justice. Oh, let's get it out. Sweet, is it? To the floor?
So there you go. That just about sums it up. This was about 2 years ago now. And is the ute still running, you may be asking? Well, yes. Yes, it is. The batteries aren't quite what they used to be. They've become a tad anemic in their old age. But yeah, she still hobbles along. And I'm also well aware that I've glossed over literally every single detail. But if this video gets any interest, and if anyone wants a detailed write-up of what I did, I'll consider it. I won't make any promises, but I will consider it. So there you go. Have a good day. I'm off to find some water before I die from dehydration. No, that's a bit intense. I'm not going to die. I'm just really thirsty. Just a quick note on the batteries. I didn't really mention how they're hooked up, which was, well, is an important detail, I suppose. But I had 15 in series, and then 2 groups of those 15 cells in parallel. So yeah, roughly 120 volts, a bit over, fully charged. Oh shit, Jeff. Watch your footing. Oh, that nice golden yellowy grass, like freshly baked bread. Some nice clouds in the distance. You literally can't get any better than that.